Today we're doing section 3.2 and we're going to be talking about the log function. This is the first day of the set of notes. We'll be in this set for a few days. So there's two different forms that we're going to be dealing with. One is called log form, one is called exponential form. So the one that we're more familiar with would be our exponential form, and that is if I had the equation x equals b raised to the y power. So notice y is our exponent, b is our base, and x is what we call the argument. That's what we're setting it equal to. So to kind of take these letters and to show you how this goes into log form, I have y equals log base b of x. So notice that b is still the base. It's not just the base of the log. The argument is now becoming the exponent. So we're setting it equal to the exponent. And then what it was originally equal to is now inside of the log. So these are the two forms. It's very important that you are able to go back and forth between these two forms. So we will do a lot of practice on that tomorrow. So for our first example, we're going into exponential form. So notice you see the word log there. We're trying to get the log out of there. So my base is 5. Whatever it is equal to is what the exponent is. So I would say 5 squared equals x. And now we are in the equivalent exponential form. Similarly over here, my base is 64 to the third equals x. And lastly, I have 3 to the y equals 7. So don't think the variable has to stay the same. It could be in different locations. So just whatever that base number is inside the log is still your base. What it is equal to becomes our exponents. So let's try and go from the other form. So now we are in exponential form, and I want you to put it in log form. So I have log base 12 of x is equal to 2. So again, notice whatever my exponent is, that's what it is equal to. Here I have log base b of 8 is equal to 3. And for letter C, we need to use natural log because natural log always has a base of e. So I would say natural log e of 9 is equal to y. So those are the two going back and forth between. Next thing we're going to talk about is how to evaluate them. So before we can get into evaluating them, we need to recall two very important rules that we're going to use in this section. So one is the negative exponent, and the negative exponent says if I have a negative exponent, it changes its place in the fraction, and it'll become positive by moving it to the denominator. Similarly, if I had 1 over x to the negative n, this would be able to move me up to the numerator. So a negative exponent just simply switches your place in the fraction, and you drop the negative sign when you move its place in the fraction. The other rule is square root. So here I have the 8th root of x to the b power. So this becomes x raised to the b over a. So notice whatever your root is always going to be your bottom value. Always, always, always. So we're definitely going to use those two rules in the next part of this lesson. So notice it says evaluate. So here, when we do these, I think it's easiest to set these equal to x to figure out what they are equal to. So to put this in exponential form, I would say 2 to the x equals 16. And then I would kind of say, okay, well, 2 to the what power gives me 16, or I could work exclusively with that right-hand side, and I could say I know 16 is 2 to the 4th power, which means x has got to be equal to 4. So as long as you can get the same base on both sides, we know that both exponents have to be equal. So for the next one, I'm saying 7 to the x power equals 1 over 49. So first I would say that 49 is equal to 7 squared. And if I want to move that up from the bottom, I'm going to make that exponent negative. So I made that exponent a negative 2, and that was able to move me in the spot of the fraction. So now I know x is equal to negative 2. Alright, so let's try 2 more. So here, again, we'll set it equal to x. I think it's just a little bit easier to do this than to try and do this all in your head. So 25 to the x power is equal to 5. And I know this is 5 to the first. On the left-hand side, I know 25 is the same thing as saying 5 squared raised to the x. And when I have a power raised to a power, I multiply my exponents. And now that I'm at this point, I would say 2x has to equal 1. We divide both sides by 2. So x has got to equal a half. And to kind of tie this in, if we went back to kind of check this, I said at the beginning that a fraction is the same idea as a square root. So if I had 25 to the 1/2 power, this is the same thing as saying the square root of 25 to the first. And I know the square root of 25 is 5, which is what I was trying to prove it equal to be. So one last one. Here I have 2 to the x equals the 5th root of 2. So again, this is implied to be 2 to the first power. So I need to get that radical out of there, and I would say this is 2 to the 1/5 power. So at this point I can now see that x equals 1/5. And again, as you get better at these, you'll be able to figure out the exponent in your head without having to really write it down. So that's all for today. We're going to pick up with this tomorrow, and then in the next lesson we're going to do some properties on logs.